Today we will learn about a little bit of the motion of an object at the, any instant of time. An object can be either of these two states. Either it can be at rest, that means the particle is not moving, implying that its velocity is 0, or it can be in motion, that means the particle is moving, which implies that the velocity is not equal to 0. Now the velocity of the particle is nothing but the rate of change of the displacement of the particle with respect to time. That means if I know the final position corresponding to the final time and the initial position corresponding to the initial time, then we can calculate the velocity of the particle using this formula shown here. Now, there can be three types of motion which is associated or linked with the object. Either it can be a translational motion, or it can be a rotational or circular motion, and third, it can be a mixed motion. Mixed means it is the combination of the translational and rotational motion. First, let me give you an example of all these three types of motion. Example of translational motion may be the motion of the car which is moving in a straight line in the road. In an atom, there is a nucleus in the center, and revolving that nucleus there are electrons. So the motion of that electrons around the nucleus is an example of rotational or circular motion. And the example of mixed motion is the motion of the tires of a moving car. Whenever a car is moving in a straight line along a road, then the tires have two types of motion. It has a translational motion along the same direction in the moving car, as well as it is rotating about its axle. So this is an example of the mixed motion. So today we will learn about the circular or rotatory motion, very basic concept of this. So let us consider a particle which is revolving around the circular path, as can be seen from this diagram, and which is having a linear velocity v. Now at any instant of time, it is making an angle theta with its initial position. In this diagram, the initial position is denoted by this horizontal arrow here. O is the center of the circle. So the position of instantaneous position of the particle or object, that can be denoted by these two parameters r and theta. Now the parameters that defines the motion of these particles are as follows. The angular position, which is denoted by the Greek symbol theta, it is the instantaneous angle made by the object with respect to its initial position. Second is the angular velocity, which is denoted by this Greek symbol omega. It is nothing but the rate of change of the angular position with respect to time. It is very similar to our linear velocity, that if I know the linear position, initial position and final position, initial time and final time, then we can calculate linear velocity. Here also the same thing is applied. And third parameter is the angular acceleration, which is denoted by this Greek symbol alpha. It is the rate of change of the angular velocity with respect to time. Now we know that behind every motion of any object there is a force according to Newton's second law of motion. Newton's first law of motion. So here also the contributing factor or the factor that controls the motion is another force, and here it is called the centripetal force. Now how we can calculate the centripetal force? We can calculate via this formula, that if m is the mass of an object, v is its linear velocity, r is the radius of the circular path, then centripetal force is given by mv square by r. Now in case of linear motion, the forces that we are dealing with is real forces, but here these centripetal force, this is a hypothetical force. Hypothetical force means imaginary force, and it is always directed radially inward as shown by the arrow in the diagram here. Now what are the relation between these angular parameters and linear parameters of the object? The linear velocity is related to angular velocity via this formula, v equal to omega into r, and the linear acceleration is related to the angular acceleration via this formula, a equal to alpha into r. Now what are the equation of motions which governs the circular motion of any object? In the linear case, we have seen that v equal to u plus at, that means final velocity equal to initial velocity plus acceleration into time. Likewise, here also we can say that omega equal to omega naught plus alpha t, that means final angular velocity is equal to initial angular velocity plus angular acceleration into time. Second was in our linear case s equal to ut plus half at square. Likewise, here also theta equal to theta naught plus half into alpha t square. That means final angular position equal to initial angular position plus half into angular acceleration time multiplied by time square. Third equation in our linear case was v square equal to u square plus twice as. Here also we can say that omega square equal to omega naught square plus twice alpha theta. That means final angular velocity square equal to initial angular velocity square plus twice into angular acceleration multiplied by the displacement of the particle. Now, if you look carefully in these equations, you can see that these two types of equations in our linear case, in our angular case, they are very look alike. That means they are very similar to each other. Only thing is that the linear parameters has been shifted to the angular parameters. So, using these formulas, you can calculate all the parameters or the quantities that defines the motion. Okay, that will be all for today. Thank you.